Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated.
In this video session, you are going to learn about the Mass-Defect and binding energy. Since we know that there are strong nuclear forces that exist among the nucleons within the nucleus, so there must be some work that should be done to separate the nucleons from a nucleus. Now, why I say that there must be some strong nuclear forces is because the protons in the nucleus, they would repel each other, so the nucleus cannot remain stable. That means there is some other kind of nuclear force which is an attractive force and binding all the neutrons and protons together within the nucleus. So the stability of nuclei, that also indicates the presence of the strong nuclear force. Now, that means in order to completely dismantle a nucleus into its constituent nucleons, some work has to be done to separate the nucleons. And how do we do that work? Of course, by overcoming the strong nuclear force which is acting between them. So, this work is known as the nuclear binding energy. So, now we understand where does this binding energy come from? Because we have learned so far whenever some work is done, it gets stored in one or the other form of energy like potential energy or kinetic energy. And here, because we are overcoming the binding force of the nucleons, so the name given here is the work done will be stored as the nuclear binding energy. As you can see here, this is a neutron and a proton together, and some kind of photon strikes and energy is there applied to separate these two neutrons. So that is known as the nuclear binding energy. So we can define the binding energy of a nucleus is the work or energy required to completely separate the nucleons of that nucleus, or even conversely the reverse of that, the binding energy is released when a nucleus is assembled from its constituent nucleons. So either you can say you're separating the nucleons from the nucleus, breaking it up, then you need the binding energy, or even the binding energy is the amount of energy that will be released when a nucleus will be assembled from its constituent nucleons. And this energy is given by the famous Einstein's relationship E is equal to mc square. And here you would understand a new term that will be introduced, that is mass defect, because so far we have always considered the mass to be a constant thing. But you are going to learn that the mass of the constituent nucleons which are forming the nucleus is greater when they were actually far apart than the mass of the nucleus formed by bringing the nucleons closer. So, ideally, when nucleons combine, they should have the same mass of the nucleus, but this is not the case. So, the mass of the constituent nucleons is actually greater than the mass of the nucleus which has been formed from them, right, by bringing the nucleons together. So, that is why that difference in the mass actually corresponds to this energy. So this is also known as mass energy equivalence. So let's see what that difference in the mass is called. So there's a new term introduced here, that the mass of the protons plus the mass of neutrons is larger than the mass of the nucleus they form. So that difference in the masses is known as mass defect. So if I say delta is generally used to denote the mass defect. So delta is equal to total mass of nucleons minus the mass of the nucleus. So if we say that MP, that's the mass of protons, and Mn is the mass of neutrons, and M capital N is the mass of nucleus formed. Then for an element ZXA, of course you identify that Z is the number of protons and A is the number of nucleons, that is protons and neutrons together. So what is going to be the mass defect delta? That will be the total mass of the protons, that is Z times mb, plus the mass of neutrons, which is the number of neutrons is A minus Z, that times mn. That total mass of the protons and neutrons together minus the mass of the nucleus. This is how you denote the mass defect. So if you know the number of neutrons and protons, you can find out the mass defect. So that's all for this video session. In the next video session, you will understand to solve a couple of problems based on mass defect and the binding energy. Thank you.